Okay, hello. So we continue with question 4, that is physics 1010. So here we want to determine if a container is leaking or not. Okay, so we have air in a container, and now this air is observed to expand from an initial volume of 22 liters to some final volume of 53.6 liters as the temperature is increased from 27 degrees Celsius to 750 kelvins. Okay, so now we want to know whether this container is leaking, and if it is, we need to know how much air has been lost or how much air has leaked out as the air expands. Okay, so notice here that the original, or rather the observed final volume is 53.6 liters. Okay, so now using the values of the initial volume and the change in the temperature, okay, we are going to obtain another value of V2, which is more like the theoretical value, and then we compare that value to the actual value which is given in the question. Okay, so this is the observed value of V2 right here, 53.6 liters. So we are going to obtain another value of V2, and then we see whether or not it is greater than this original, or rather the observed value, from which we can make a conclusion to say whether or not the container is leaking. Okay, so at constant pressure, we know that what we have is P V over T being equal to PV2 over T, but because the pressure is constant, it's going to phase out, or rather it's going to cancel out in the expression. So we remain with V1 over T1 equals V2 over T2. Okay, so I am hoping that you have gone through these laws. All right, well, I'm sure you have. So once you do that, the pressure is eliminated automatically because it is the same for both the initial as well as the final. All right, so from this we are able to obtain an expression for V2. Okay, after reaching this stage, we can now obtain the expression for V2 as V2 equals T2 times V1 over T1. Okay, so if this is our expression for V2, and we know that the observed value of V2 is 53.6 liters, then what is this theoretical value of V2 looking at the other conditions such as the temperature and the initial volume? Okay, so we know that the initial temperature converted to kelvins is 300 kelvins, and the final temperature, which is already in kelvins, is 750 kelvins. The initial volume of the air was observed to be 22 liters. Now what is the final volume? Okay, so let us find now the final volume. In this case, with our expression of V2 there, we simply substitute the values. We know that V2 equals T2 V1 over T1. So we go ahead, our V2 equals T2, which is the final temperature, multiplied by the initial volume of 22 liters divided by the initial temperature of 300 kelvins, from which we're obtaining the value of V2 to be 55 liters. All right, so now if we compare this value of 55 liters to this other value here, we notice a difference, okay? The observer only saw the air expanding to 53.6 liters, but in the actual sense, the expansion should have been 55 liters. So this implies that there is more air that has actually gone out of the container. Instead of having 55 liters, we only observed 53.6 liters. So meaning whatever the remainder there, or the difference between the two volumes, that is the air that has been lost, or the air that has leaked out. All right, so we go ahead here and say theoretically the value of V2 should have been 55 liters. Okay, so we get the difference between the values of the volumes. We have 55 liters, which was supposed to be our final volume, minus the observed volume, which is 53.6 liters, giving us a volume of 1.4 liters. Okay, so if we are saying we were supposed to have 55 and we only had 53.6, then it means this 1.4 liters of air has been lost, and therefore we conclude to say the container has a leakage. Okay, the container has a leakage. All right.